We're asked to solve the equation sine x equals cosine of 2x minus 1 for all x values between 0 and 2 pi. We have a mix of trig functions, both sine and cosine, and it would be most convenient if we could get them down to just one trig function. Luckily, cosine of 2x has several forms that we can use. For instance, cosine of 2x is cosine squared x minus sine squared x, but that's not that useful because it still mixes sines and cosines. We also have that it's 2 cosine squared x minus 1, but then we would still have a sine x on the other side, and that would mix the two functions that aren't that useful. Or finally, we can think of it as 1 minus 2 sine squared x, and that won't be useful because our equation will have just sines in it. We'd have sine x equals 1 minus 2 sine squared x minus 1. Of course, this one and that one will combine to be 0 and disappear, and we'll be left with sine x equals just minus 2 sine squared x. We can probably make that a little neater. 2 sine squared x. So we've reduced our equation to being sine x equals minus 2 sine squared x. We're going to add 2 sine squared x to both sides to get 2 sine squared x plus sine x over here and 0 on the other side. And then probably the safest thing is to factor out a sine x and be left with 2 sine x plus 1 on the inside. By the 0 property, if two numbers multiply to 0, then one or the other must be 0. So either sine of x equals 0, or 2 sine x plus 1 equals 0. The first one is solved at x equals 0 or x equals pi. We're in radians, and they asked us to be, as we can see here, they've asked us to be in radian mode, so we have to leave that as it is. The other one is solved by 2 sine x equals minus 1, or sine of x equals minus a half, and that's solved by x equals 7 pi over 6, or 11 pi over 6. Okay, how did we know that sine x equals minus a half gave us those solutions? Well, we look at the equivalent and we say sine of x equal a half would have been solved, in the principal angle at least, by x equals pi over 6, which is of course really just 30 degrees if you prefer to think in degrees. But we don't have that. We have sine x equals minus a half, which means we need the angles who have reference angles of pi over 6, but sine is negative. So sine is negative in quadrants 3 and 4, and we should be down by pi over 6. So something like this is pi over 6, and I'm looking for that angle, which is pi over 6 past pi, so this would be pi plus pi over 6, which of course is 7 pi over 6. The other place where sine is negative is in the fourth quadrant, and again we would be down by pi over 6, but now we're short from 2 pi for that angle by pi over 6. So this angle would be 2 pi minus pi over 6, but 2 pi is the same as 12 pi over 6, so we have 12 pi over 6 minus pi over 6, which of course is just 11 pi over 6. And that's where our two answers came from. A final check on our answer would be to actually graph it and to see where those two curves intersect during that range from 0 to 2 pi. A quick thing through Desmos gives us this graph where the shaded region is the primary range from 0 to 2 pi. And we can see that we have our solutions at 0 and pi, and our other solutions at what is believably 7 pi over 6, a little bit more than pi, and 11 pi over 6, a little bit less than 2 pi. So we can see that our intersections agree with our desire, and there's our solution set.